Hello, folks. This is Answer Everywhere. We're going to do some sight reading of some code we've never seen before. Today, we're looking at React Native. This was a request from user Friction on Discord. I think he's also Friction on YouTube. But we'll see what makes React Native tick. So we can scroll down here and we see that it's a lot of C++, more C++ than JavaScript. And in fact, if you add Java and Kotlin together, I imagine both of those are mainly about making things work with Android. Then there's more of that than JavaScript as well. And then there's some Objective C++, which frankly I didn't realize was a thing. That's two kinds of objects. We have the Objective-C objects and we have the C++ objects. Do they fight? Do they work together? I don't know. I don't develop for the Apple ecosystem. And then we have regular old Objective-C. And given the breakdown here, we can make some guesses or assumptions or hypotheses about how this code works. And one of the guesses that pops out to me is that this is mostly going to be glue code in JavaScript to set up the familiar React ecosystem interface. And then most of the code is going to be about taking the ideas and metaphors in React and making them, implementing them on essentially the back end on Android and iOS. And I don't know if they support other ecosystems like other mobile OSs. Maybe we can find out if we do a search for Android. Okay, so iOS and Android. We have looked at Flutter, which is a similar cross-platform tool for mobile development. And we've looked at React. This is the first time we are looking at React Native. Yo. Oh, hey, Friction. Friction is here. It's good to see you. All right, so let's check things out. Jest is going to be testing. I think packages is where I want to see things. We have gem files. Isn't that a Ruby thing? We have Ruby gems. I'm wondering if Ruby is mainly for code or like part of the build system. Can I do a star dot? What is Ruby? RB? Okay, it doesn't seem to like that, but maybe my search is wrong. Okay, so let's find packages. We don't need gem file. All right, packages, and then this is going to be a lot of stuff. Hermes, I think I recognize as a meta thing. Maybe hello, Lewis or Louis Perry Mills. Thank you. They say they're woo. Absolutely loving your channel so far. Happy to be able to tune in live. Well, thank you so much for joining us. Okay, Hermes is a JavaScript engine optimized for React Native apps. So that makes sense. JavaScript engine, I guess this is different from V8. I don't know if it's built on V8 in any way. You can maybe do a search for Hermes V8. They differ in their performance and use cases. Okay. So these are, I'm going to guess that these are not actually, one is not dependent on the other in any way. But I see a bunch of things. I'm not a JavaScript developer, but I know enough to know that Babel, things like Babel and ESLint, this is linting. Babel is, I forget what exactly, I think maybe packaging things up. Hermes inspector, I'm going to guess is something like static analysis. checking for various things. Poly normalized color is maybe, I don't know if this is normalized color at the level of themes or at the level of like display, but I think we're just going to ignore it. Polyfills, I think, are mainly going to be almost like utilities. And we have a bunch of React-native stuff. And this seems like this is probably where the real gold is going to be. Bots. Why do you need React Native bots? I don't know. Preset and transformer, I'm going to guess, are not so important, but transformer might be. Code gen TypeScript test, we can ignore. And then here, we probably want code gen. Pop-up menu Android gets its own package. I'm wondering if these are packages in the sense that these are from this repo, these get deployed as npm packages. That's possible. And here is the React Native thing, and then here is React Native code gen. Yeah, okay. So these are packages in the React Native namespace. So I'm going to assume that everything we really care about, at least initially, is in the React Native package. And so we have libraries, React Android, React Apple. I'm hoping these are the implementations of the specifics for these platforms. Android on its own, I don't know. Flow is some JavaScript, I think, typing stuff. Let's look that up. All right, that should do it. Okay, it's a static type checker for JavaScript. Okay, so that's Flow. Gradle is a JVM, Java ecosystem-based build system, probably is there for Android. And then we have Source, which some people, I think, use mainly for C or C++ source, so those might be C or C++ files and types. And then everything else, I think, is mainly like metadata. Where is the template? The React Native template has moved from shipping inside a React Native package to its own package. Why has it moved? And there's some RFC for it. Okay, I think this should be good. Did we open libraries? I don't think we did. I'm also not positive we opened React itself. So let's open React in this tab. And then we see base, core modules, CXX bridge. I don't know if CXX includes, it probably includes C and C++. Does it include Objective C++? I don't know. CXX utils, fabric, internationalization, inspector, modules, profiler, resources. Okay. So this, I think, is the important part for the foreign function interface, going from JavaScript to C and C++. I don't see Java. I don't know if UI and utils and views are worth looking at, but there's a lot here, and I'm not sure really where to focus. Here's React Android. We have API and source. Maybe we should pop these all out of their own things. So API we'll look at, source we'll look at, and then the API is nothing, basically nothing. It says C style, or this is, I guess, Java, public abstract class, etc. And then here in the source file is going to be Java stuff. JNI is going to be the Java native interface. First party, React, pre-built, Fabric, dev support, feature flags, Hermes, JNI. I don't know where in here to go. But let's just, I guess, open this up. And then we'll look at the similar for Apple. And something about deprecation. RCT deprecation. C macros to identify deprecated APIs at build time. So where else is the Apple stuff? It contains code to ship React Native apps to Apple devices. The dominant language is Objective-C. But I don't see any Objective-C. Right? React Apple, and then this RCT Foundation thing. Huh. What's up with that? And then here's React Common. And we have some call, like a call invoker. That might be important. CXX React is going to be more like foreign function interface stuff. Hermes might be important. JSC, maybe JS compiler, JSI. I don't know what that would be. These all might be important. JSI executor. And what about the React folder? Okay, and we have bridging, config, debug, feature flags, native module. I have a feeling this might be the cool place. There's a lot of folders. And then we have performance timeline, renderer, runtime, timing, and utils. This seems promising. And in bridging, we have things like the basic types like array, Boolean, string, function, number, object, promise. And in native module, we have a DOM, no sub, but we have core, DOM, and some feature flags. And I think I can just ignore everything else. And in core, we have React Common and some stuff about Turbo CXX module, callback wrapper, turbo modules. I don't know what those are. And then we have native DOM and native DOM.cpp. Okay, so I think for the first time maybe on this show, I feel pretty uncertain about what a good entry point is. Renderer seems promising. What language is this in? Let's look at renderer core. We have C++ here. I feel like React Common has my current vote. But I want to know where the C++ files are. Not C++, the Objective-C files. So let's open yet one more window. Let's verify that I can do like a search like star.c and find files. Can I? Not really. Can I do file type? How about search syntax tips? We can do repo language. Okay, let's try language. Objective-C. We have, wait, what? So do Objective-C files end in C and C++? Hello, Friction. The first JS framework that you worked with. Cool. It seems pretty easy to get working. I took a look at a couple of the tutorials for the basic apps. And it seems like when it works well. Did you have any, do you still use it out of curiosity? Okay. The extension is .m for implementation. And then I don't know what the header is. Implementation. Okay, so these .m files do seem to be C++, or rather Objective-C, and they're in base. Well, this is, hang on, that's a H. I don't know if there's a way of knowing whether that's a C++ header. You know, I don't really care for GitHub search, but let's try Emacs. Okay, we have Hello World for iOS, and we have React Native libraries with a big L, which I think is a common iOS or not the I, but the Mac OS idiom. Maybe it's also for iOS. I don't know what RCT is. That might be another iOS thing. And then in React Base, we just, I guess, maybe commingling the C files with the Objective-C files and stuff. Although I don't see any C files. This is React Native libraries, React base surface. So I'm guessing libraries is the place to be if we want to see iOS stuff. Or no, we're not in libraries. Yeah, I don't know. So let's look up RCT. Roller Coaster Tycoon. How about RCT React? Is RCT just React? Stands for React. Okay, so where are the React Native iOS files? All right, so it doesn't seem like they're in one place in particular. So I'm just gonna like plow through and see what we see, and if we are longing to see more iOS stuff, we'll look more for them. And so, with all of that said, I'm gonna start at bridging. Right? Yes, let's do it. Okay, so bridging should be about the foreign function interface. So we have a string. I don't know what that makes that different from any other kind of string. Got it. Friction says it's been a while since they've used it. Okay. So I don't know what we expect to see. Pragma once. I think that just makes sure this is like loaded once. A non-standard but widely supported preprocessor directive designed to cause the current header file to be included only once in a single what? Single compilation. It's the same as include guards, but with several advantages, including less code, avoidance of name clashes, and sometimes improvement in compilation speed. Okay. All right, so we're going to include React bridging base, which is not the first thing we looked at. And we're in the namespace Facebook React. That all makes sense. This is C++, I think, unless it's also valid Objective-C. And we have some template that has this bridging function. It takes a standard string, which makes sense because we're in the astring.h file. And, or rather, I guess this is the name of a struct that is templated by a string. And we have this from.js function, which is going to take a JSI runtime and a JSI string called value. And we're going to take the value and call UTF-8 on the runtime, which seems a little bit unusual. I would have guessed, if I had a wager, I would have guessed we call a function on the runtime and pass in the value. Here we are calling a function on the value and passing in the runtime. And we have this, and that returns a standard string. And then we have this to.js, which returns a JSI string. And it consumes a standard string. And we're going to call JSI string create from UTF-8 the runtime and the value. And similarly, for the bridging of string view, this is bridging of string. String view should be like a slice into a string, like a region of memory, as opposed to the string itself. And we're pretty much going to do the same thing, except we have to.js implemented and not from.js. I guess there's no way to get a string view from JavaScript, but if you have a string view, you can turn it into JavaScript and you call create from UTF-8 on it, same as here. And you reinterpret cast by taking the data in the string view and the length of the data, and you turn it into a const uint 8 star, which is basically a string. And you're just taking that string view, the stuff that's viewable in it and turning it into its own string, essentially. And then we have this bridging of a const char star, which I think this is saying is the same as a string view. And similarly, char of n is the same thing. I had kind of forgotten you can templatize structs, which must be what this is. So let's just verify that I'm not forgetting the C++ syntax here. So it does this, create a templatized struct called bridging and define it to be the same as bridging of, is it string view or string? Okay. But so why do you need it's a specialization of the bridging template. Okay. All right. So that's string. That tells us a little bit about how we're doing. And what else do we have? We have array. Okay, so we have this bridging static. Again, this is, well, hang on. I don't see bridging here, but we have bridging static. I don't know what the difference there is. And it doesn't seem to, the bridging thing itself doesn't depend on the type, but the template on the whole depends on the type name T and the size N, which makes sense because this is an array. So this should be an array of some type of size N possibly. At any rate, I guess bridging static means it's like a static function we're going to call. And we have this 2JS. We're going to pass in the runtime. We're going to pass in the, did we get an array? Oh yeah, no, we are passing in a const T reference array. And we're passing in a shared pointer JS invoker thing, which is a shared pointer to a call invoker. And then we're going to call 2JS, passing in the runtime again, and the array, and the invoker. And we're going to make an index sequence of n. And I don't know what make index sequence of n is, so let's look that up. You're welcome. And it Sarkar. I assume this might be like 0 to n or 1 to n. Array to tuple impl. Let's just ask the AIs. It's a template metaprogramming utility that generates a sequence of compile time integers from 0 to n-1. Okay, compile time integers. Okay, great. So this is more compile time metaprogramming. Okay. Why we need them, I'm not sure, but this is something to convert an array, I guess, to JS. Maybe this is like an indexing argument or something. And similarly here, no, this is basically a class, but we have a template which has size T, and I'm not sure what index is doing here, where it came from. But then we have this 2JS thing that returns a JSI array, which is static. And I don't know how it differs from this. Oh, this has create with elements. And we call bridging 2JS. We're going to call get with the index on the array and the invoker. Okay, so this is I still don't know where index came from. But, oh, no. Index is part of the template. That's defining something that we're templating on. Okay. And then how are these different? They just take different arguments? And why is one private and one public? I guess the private one is like an implementation detail. And I guess that's what is being called here, the implementation one. All right, cool. So this is converting JavaScript arrays to C++ arrays, and then the other file is converting JavaScript strings to and from C++ strings. Boolean, etc. should be the same. Bridging should be setting up or no, it's not setting anything up. It's just including a bunch of stuff. Let's see how promises work. Or do we care about convert? Dynamic might be mildly interesting. Event emitter might be interesting. A function should mostly be about, I guess, setting up the calling convention. Let's just look at a few of these and see if there's anything that really pops out to us as fascinating. Index, I closed the file, but I think index is an argument to the template. So when you have the template syntax, this doesn't have any arguments, but somewhere. Yeah, so this is a template, and it takes like a variadic number of arguments, and I forget what type name is, but somewhere we should be able to see args. So when you create an async callback, let's see if we can find calls to this template. Can I do? So for example, this async callback, you tell it it's of something, it's of standard string. And then you should be able to say it's of multiple things, I think. Let's look up the C++. Or is it C? It's C++. Type name. Is type name you just always have it there? Class T, type name T. Let's look up template C++ type name. What is use class or type name for template parameter? Is there a reason for one or the other? Strup, the creator of C++, originally used class to specify types in templates to avoid introducing a new keyword. Some of the committee worried that this overloading of the keyword led to confusion. Later, the committee introduced a new keyword, type name, to resolve syntactic ambiguity. Okay, so I guess they mean the same thing. There might be slight differences now, but type name is just it doesn't add anything new. It's essentially just syntax to tell you that that's the sort of thing that we're putting in. But at any rate, these are args, and I'm pretty sure that as with other parts of C++, this means we have a variable number of arguments, which is also why it's plural. And so index, I think, was the same way to answer this question here. Okay, so dynamic's going to be hard to understand, I imagine. Function's going to be hard to understand. I'm kind of curious about promise. So we have a type name T. So this is templated on some type. You can say like promise of a string, just like I think in JavaScript, it's essentially templated on the type. An async promise, again, we're going to take the runtime, and we'll look at the runtime, I guess, after we look at all of these things. And we have a shared pointer to the call invoker, which is a file I've opened up somewhere, but this is somehow going to give us a handle to call, I assume, JavaScript functions from C++. And then we have some shared state. Yeah. And then we're going to, in the runtime, we're going to, I guess, ask for maybe some global variables. maybe this is using like a service locator sort of pattern. And we're going to call get property as function promise. And that's going to give us, I guess, a constructor. And then we're going to call as constructor on that constructor to get a promise back. We have auto, so I don't know what type this returns, but the call as constructor is going to take in the runtime and this JS converter. And since we're calling 2JS, I'm guessing this is like a C++ reference to a JavaScript promise, and not vice versa. And then we have promise holder, which we're going to make a shared pointer to the promise holder by taking the promise, turning it into an object, presumably I'm going to guess a JavaScript object. And we've got this long-lived object collection get rt add promise holder. And this I'm going to guess is essentially, well, it's going to be a collection of long-lived objects, possibly or presumably for garbage collection, so that we know that these are expected to live long and hopefully prosper. And then we're going to take this state variable and set its promise holder to promise holder. The shared state can retain the promise holder weekly now. But it seems like we're assigning the promise holder variable, so we don't have, it seems like we can only have one promise at a time potentially. And then resolve, well, is this part of the same template? I think so. So resolve just takes a value, and we've got this lock, some sort of mutex. We're going to lock it on the call lock on the state mutex, and if state resolve, then we're going to try to call the function call on the value using standard move to change ownership, and then we're going to call resolve reset, and then reject reset. And reject, we're going to also lock, we're going to call the reject call and then reset in the opposite order. So I think that, so reject with an error. So these are promises. We could resolve them or we can reject them. And I think that this is, again, C++ interfacing to JavaScript promises. So you ask for, let's take a simple example. Let's say you ask for a window, or you have some list-like object, like a list of emails. You're building an email client. Then the objects that go into the list, I think, are usually going to be like native iOS or Android objects under the hood. They might have things like widgets or whatever. And you get back a promise of a bunch of them, and then in order to convey to the JavaScript side, essentially to the UI layer, whether something was successful or not from C++, you can use these, and maybe we will see some of them being used. That's my sense. I'm not 100% sure which direction we're going, but it seems like that's the direction we're going. An object, this should just be about, I think, converting to JavaScript objects. We have from.js. When we call from.js, then we, again, pass in the runtime. We pass in the JSI object, which we're going to call value, and the call invoker. And then we're going to, and we have this result thing. We're going to call get property names, which is presumably going to be, I guess, some JSON stuff associated with the JavaScript object. We'll get the length of the names. We'll iterate over all of them using their length, calling get value at index. And then we're going to result in place. So adding to this like C or C++ list. And we're going to call from.js string on all of the properties. And I'm not really sure what JS Invoker is going to be doing here. Maybe it's needed for from.js. And similarly here, we're going to get the property by asking for the mapped type. So this, the code we're generating is all, this call is templated inside of the loop. Because we don't know yet what the type of the thing, what the type of the JavaScript property is. And so on. Okay, so I'm getting a sense now of what it's up to. Value, I think we're going to ignore because that should be relatively straightforward at this point. For function, we have this async callback stuff. We've already seen promise, so maybe we don't need to look too closely at this. But again, we take a runtime and a function, and an invoker. We have, I guess we're going to overload operator, the call operator, and we're going to implement a call function, which is just, we're going to take some args and then call a call with args, giving it a null pointer. I'm not really sure why. And I forget what standard forward is, but really passing in the args. Let's look up standard forward. Is used to convert the named R value references T1 and T2 to unnamed R value references. What's the purpose of doing that? You have to understand the following problem. You can read the entire problem in detail, but I'll summarize. So this is some R value, L value stuff. I do care enough to understand it, but not in this context. But we have call with priority, which we can pass in some scheduler priority. This is probably to do things like some stuff like the screen redrawing is higher priority than other stuff like synchronizing the database. And so that's probably what that's for. And we have call with function. And I think that function is not really about calling functions. This is really about having a rich library of doing things like asynchronous callbacks and what was it we just saw? Like call with priority, callbacks, those sorts of things. Okay, so that's what's in function. And then event emitter, we have this emit function, and we're going to take a standard function from a JSI value of like a runtime and or a reference to a reference. We're going to call that converter. We're going to lock the state. Can I explain? It's on the list. Oh yeah, sure. I can. I will. And then we're going to iterate over this. That'll be like end of December-ish though. We're going to iterate over these somehow we have listeners. Oh, okay. We're going to get the listeners from the state. And then for each listener, we're going to call, I guess, capturing the converter in a essentially like a Lambda style function, passing in the runtime and the JavaScript function, and then we're going to call the call. We're going to call the call method on the JS function object or value or class or whatever it is. And we're going to pass in converter of RT. That's what emit is going to do. Why? I don't know. Okay, so essentially we're just calling the JavaScript functions that are passed in, doing the necessary things. So this is kind of like, this to me kind of looks a little bit like a Haskell monad or like a category theory thing where like, there's only one thing that you want to do. You want to call some functions. And then everything else is just kind of like you have to set up things so that the arrows go the right way, that the types are aligned. And there's again, just one way to do it. And it might be hard to figure out how to get it to compile, but once you do, there's nothing else really you could have done. That seems, that's the sort of vibe I get from here. And then args, and that's emit if you pass in functions of a value, I guess, that depend on our runtime. And here's emit of like a variadic number of values. Again, we're going to lock. And we're going to iterate over the state listeners. And then we're going to call listener call static casting the value into args. Okay, so that's that. Now let's so now that we have seen that, first of all, before I close this, I just want to know if this is about garbage collection, the long-lived objects. Allow release. Allow the sweet release of what? Something. So long-lived object collection is a singleton thread-safe write-only collection of the long-lived objects. So wait, there's some collect stuff up here. Okay, so I don't know entirely what this is about. And so I think the next thing we want to do is we want to see what is up with the runtime. And where do we find that? Runtime. So I'm going to do this. Give me about 1 second. I'll be right back. All right. So the be right back screen was cool. I stole it from the internet. All right. So here's the runtime thing, and this is like some sort of like God context object that we're passing in everywhere that we're doing the bridge between C and JavaScript. And in fact, one thing that we saw, but I didn't draw attention to, and I don't think I like thought explicitly about yet, is the boundary between C, or I think that was all C++ and not raw C. I don't know if it was valid Objective C. I don't know what Objective C looks like, but at any rate, it's between C++ and Java. Sorry, C++ and JavaScript. It's not between. There was no Java. There's no like JVM Kotlin stuff. So I'm going to guess that we always interface between JavaScript and C, and then maybe it's in C/C++ that we interface with Java. Although I don't know. So let's actually look up Objective C++. Objective C++ support. I really just want a syntax example. Oh, Gemini will hook me up. We've got these @ signs. That's a little bit weird. This, okay, is not what we were looking at before. And then let's take a look at Objective C. I'm sure many of you watching this have used Objective C and know what it looks like. Again, we have these @ symbols. I don't know if @ symbols are necessary, but at least I get the impression that that was not necessarily going to be compiled by a C, or rather Objective C compiler. So we have React instance header and the implementation file. Is this the thing that we were always calling? Can I revive from the dead my whole window? Oh yeah, it's this JSI thing I want. The runtime JSI. So where can I find JSI? Include JSI. Is there a JSI.h? There is. So I think this is where I want to be. Let's take a look at this folder 2 folders up, and that's not so interesting. It just has the JSI folder and some nonsense. Okay, we'll look at JSI.h and JSI.c++. And maybe this JSI lib. Okay, so we have this kind to string. So we're going to stringify a kind. It takes in a value in a runtime RT thing. And runtime is from where? I don't know. Maybe it's defined here. And if v is undefined, we return the string undefined, and so on and so forth. If it's null, we say it's null. If it's a symbol, we say a symbol with a space in between, and so on. Then we have this call global function, which will take a runtime, a name, and an arg. Get as property function. We'll try to create a JS error. But this doesn't look like get as property function. That was a function somewhere, right? sorry, get property as function. Okay, so that function is defined here. I don't know why this comment looks like it's supposed to be on top of that function, but maybe there's some reason it's here. And if the failure is in building a JS error, this will lead to infinite recursion. This function is used in place of get property as function when building JS error to avoid that infinite recursion. So the bottom line up front, I would put this sentence on top. But at any rate, we have this call global function. It's going to take a runtime, a name, and a value. We're going to again get the look at the globals in the runtime, get the property of. I think we always have to pass in runtime, but we're going to get the name, the property name, maybe. If it's not an object, we'll do some stuff. We'll like fail out. If it is an object, we'll call get object passing in the runtime. That will give us a C++ thing that's called an object, which I think is probably a reference to the JavaScript object. We'll check if it's a function and so on. And then if it's a function, we're going to call get function passing in the runtime. And then we'll call it by calling f.call runtime arg. Have I ever tried contributing to some open source project? I have. I've contributed a fair amount to some open source projects, but not too much recently. And that's more about time available than anything else. It's also hard to decide. It's hard to decide where your contributions are going to be most helpful. I think that's maybe the hardest thing. Here's the decode but I'm curious, have you guys contributed to open source projects and how have you found it? So this is the decode UTF-8 thing that we saw before. This is just going to do some manipulation of the bytes. And that's an interesting thing to, I guess, like an interesting exercise probably to do, but we're not going to look at it closely. Here we have some prepared JavaScript. We have a mutable buffer, host object, I don't know what that is. And here's runtime instrumentation. But where's runtime itself? So over on the right here, I think we can get can I have like classes? Can I have runtime? Let's try this. We're going to take this. I'm looking at the C++ file, which is probably better to look at the header file first. So can I take this? And is this a valid path? And let's see if I can jump to where I want to go. I think I have too many React natives. Let's try this one more time. Let's just do a search for JSI. Okay. So in Emacs now, let's look for a runtime. And we can jump to, that's some integration test, a callback wrapper. JSC runtime.c++ is promising. And there's probably also a header. And can I just jump to the other file? I forget what that command is in Emacs. Okay, so the header is not so interesting. We have this make JSC runtime. And let's see what this is about. Can I read MariaDB code? I can add it to the list, but I don't have a. Let me just make a note in Discord, I guess. I'll add it to the list, but it might be a while. We have looked at Postgres, which is probably the closest thing to MariaDB. Okay, so I think this is probably the runtime. Not sure. We have JSC runtime, and what folder are we in? Okay, we've got a lock. or rather, yeah, something locky. We can lock and unlock. The JSE runtime is going to extend the JSI runtime, which is what I really wanted to see. But where is it defined? What if I just search for class runtime? Or is it part of Hermes? Let's try one more thing. We'll search for we'll just search for class runtime. I should have searched for class runtime with no. Run class runtime, runtime scheduler, test lib. Let's try runtime with a space. Okay. What if we do Hermes runtime? Yeah, this is promising. I think the runtime is actually a Hermes runtime potentially. Runtime stats, runtime state. What about, again, class runtime space? Somewhere this is defined. I don't really know where it's defined. Maybe there's like maybe there's an include here that will tell us something. We're including algorithms, heap, align. Using Hermes. I don't know. I don't know where this thing is defined. Let's just try one more thing, looking up class runtime with a space in using the GitHub search. And one more time. Maybe it's a struct. I don't know. It's possible it's like a struct and it's the syntax I'm not getting right. But at any rate, we've got runtime instrumentation. Are we including Hermes here? Where's the top here? We are not. We're just including JSI and instrumentation. And we have no structs. Okay, fine. Although this is not the header. Oh, it's here. Why did I not find it before? No, oh, that's just a declaration. What are we importing here? See, these are all like standard system library things. And this is some defines for JSI export stuff. Base class for buffers. Runtime does seem to be a class. I don't know where it's. Oh, here we go. Oh, it's because they had this JSI export here. That's the reason I couldn't find it. Okay, represents a JS runtime. Phew. Movable but not copyable. Note that this object may not be thread aware, but it may not be thread aware, but cannot be used safely from multiple threads at once. The application is responsible for ensuring that it is used safely. This could mean using the runtime from a single thread, using a mutex, doing all work on a serial queue, etc. This restriction applies to the methods of this class and any method in the API which takes a runtime reference as an argument. then some stuff about destructors. Okay, so this is a little bit weird. It's not thread safe. You might have to do some locking and so on and so forth. And the functions we have, can I click on this on the right here? And first of all, get rid of the search part. This is not going to be. All right, never mind. GitHub. All right, so what functions do we have? We have evaluate JavaScript, which is going to evaluate JavaScript. I assume evaluates the given JavaScript buffer. Source URL is used to annotate the stack trace if there is an exception. Okay, so they'll tell you like where, I guess, the JavaScript code was that is causing this exception, even though we're evaluating it in C. This function should only be used when there isn't another means through the JSI API. For example, it will be much slower to use this to call a global function than using the JSI APIs to read the function property from the global object and then calling it explicitly. Okay, so you're not supposed to, I guess, use this directly. I assume they use it under the hood a lot. We have prepared JavaScript. We're going to process it into a form optimized for execution or compiling or etc. We're going to evaluate the prepared JavaScript. I guess this is probably just like JIT compiling or something along those lines. We have a microtask. I don't know what a microtask is, but we're going to queue one in the JavaScript VM internal microtask, aka job in ECMA 262 queue to be executed when the host drains microtasks in its event loop implementation. So this is what? Some ECMA standard, I guess. Is this the definition of the language itself? Yeah, this seems to be the language specification. I don't know, maybe the microtasks are in the specification. Yeah. Draw an artistic interpretation of microtasks in JavaScript. Okay, and then there's more stuff about microtasks. We have the global object. I guess it's maybe like a JavaScript object that's global, and that we were using that to look up things. I don't know what it is under the hood. I don't think we've seen the object class yet. And we have a description of the instance, the runtime. We can check whether it's inspectable, and we have some instrumentation for things like metrics, extracting metrics. We have this. We have a pointer value struct, which we can invalidate. And we have some functions like clone symbol, clone big int, clone string, and they return pointer values, pointer value stars. And we create names from ASCII and so on and so forth. We can create an object. We can check if something has native state. We can have these get property things we can call on an object. These are like getters and setters, except where I think we're going to peek into a C++ model of a JavaScript object and get this stuff. Host function and host objects. I'm not sure what host function and object are, but those are things that we can look at. We can check if something's an array, whether it's a function, and so on. And so this is a lot of stuff. Again, this is essentially like a God object that's keeping track of all of the things. And it's going to be, I guess, global. Presumably you have only one of them per app. And you have to pass it into all of the functions for converting between C and JavaScript, presumably because it has a bunch of like runtime data that you need to know about. And so let's jump over to the implementation. I'm not really sure what it is we would want to see in the implementation at this point. I guess there's not really anything at this point, the next thing I want to see is probably what an object is. Let's see if there's a class object. Let's see if there's a class JSI export object. There does seem to be. Okay. So it does represent a JS object, which makes sense. It's movable but not copyable. It extends public pointer. So it's I guess like a kind of pointer. You can create from a host object. Maybe host is like the native C++ or rather native iOS or Android stuff. We have some strict equality function. You can get a property, passing in the runtime, and the name of the property. I guess we could look at the get property function and so on. But we have a bunch of methods. It doesn't seem like yet we have state. We can get the native state, set the native state. We have some protected functions. And runtime and value are friend classes probably for testing. And then we can have a weak pointer to a JS object. An array, it says, represents a JS object which can be efficiently used as an array with integral indices. So I guess everything would have to have the same type. And an array buffer. I don't know if there's like it seems like a dictionary would be, what do they call them? A value. Here's value. Represents any JS value, undefined, null, boolean, number, symbol, etc. Map, unordered map. I don't know. There should be like a general mapping from strings to values. Let's take a look in the file we were just in that had the runtime implementation. So let's look at get property. As object. I just want like the get string property thing. Obj get property. Are they defined in this one? Okay, so let's look at the C++ implementation. You're not going to jump to the end here? Oh, you are at the end. Okay. So we where's this? JSI.C++ obj get property. This seems to be defined in JSC runtime. Okay. So this, I guess, this does look like the implementation. So we're going to get a JS value ref back. We're going to cast the host. We're going to cast the JS object get private of object as a host object proxy star, which gives us a proxy back. We're going to ask for the runtime from the proxy. And then we're going to call create prop name ID on the prop name. We're going to create this return value variable. We're going to try to ask the proxy for the host object and then ask the host object to get the symbol passing in the runtime. And this is some return value. We might get an exception here, in which case we call JS value make undefined on the context. Otherwise, we're going to call ret value ref of the thing. Okay, this is completely different code. So let's look at the JSC runtime. This seems like the next step. So where were we? We were in common. So JSC runtime, I guess now we're getting into this will be like an implementation of the common stuff, I guess. JSI is maybe just the interface. JSC runtime. Let's look at the header first. And there's not much there. You can make one. And what? We're going to extend the JSI runtime so that we're going to extend the interface. And we have prepared JavaScript, which is, but what's the implementation? So at any rate, we're going to override it. And I guess that will look like this. We'll take in all of these arguments, and then we're going to call make shared JSI source JavaScript preparation on the buffer, calling standard move of the source URL, which will tell it, which is I think we're mainly keeping track of to so we can print it out. And this is just creating a shared pointer to this JavaScript preparation object. And when we evaluate JavaScript, we are going to make a shared pointer to the prepared JavaScript, I think is what we're doing here. I'm not really, there's lots of parentheses and braces. And then we do some assert. Oh, no, sorry. This is an argument to the function. We do some assert. We're going to do, I guess, like a pointer cast on the prepared JavaScript to get source.js. And then we're going to, I guess that's going to get the source code. And then we're going to call evaluate JavaScript on the source.js, passing in the URL. And then evaluate JavaScript, hopefully, is the thing that's going to do work. This is getting the source reference and the URL. The JS value reference exc is going to be start life as a null pointer, and then we're going to call it JS evaluate script. Sorry, JS evaluate script, passing the source ref, null pointer, and some other stuff. And then we're going to have this string release. So where does this come from? Hopefully, this comes from the JavaScript. What was it called? Hermes? Let's do a search for this string. No, it's an Apple thing. JS evaluate script evaluates a string of JavaScript. Okay, so it takes the context of script, this object, source URL, starting line number. So I think this is now OS or iOS. JS evaluate script, is that right? Let's see, do we have a context? Yes. Do we have a source ref? Yes. Do we take an exception as the final value? Yeah. Okay. How do we know that we are in iOS land? Maybe because we've included JavaScript core. And we've got some like if defs about iOS. And it seems like JSC is like a prefix that they mainly use with Apple, but I don't know. Doesn't seem obvious to me. So that's JSC. Let's look in the JSC folder and see if there's anything. Yeah, it seems Apple specific. I don't know what podspec is. All right, and then is there anything? What's it called? Android specific here. I'm not sure. Here's some Hermes stuff. We have an executor, executor factory. So presumably a factory for things that are going to execute things. You have a JSI executor, runtime installer, and so on and so forth. All right, so where is the... So if that's the like iOS implementation of the runtime, it seems like. And should we go back and take a quick gander at the whole thing with that context in mind? Maybe, maybe not. I guess let's do so. Maybe we'll use this panel on the right-hand side. I don't know how useful it is. Stuff like lock, prepare JavaScript. So it looks like under the hood, we're using just the iOS's ability to evaluate JavaScript. I don't know if that means that we're necessarily running in a web container. What are those called? iOS web container, I'll call it. Web containers now run on Safari. I don't think they're actually called web containers, are they? So I think web view is maybe what they're called on Android. Maybe they are called web. So WK web view. Let's look for the word web view here. So there is some stuff with WebView, but I don't think it's just a WebView app. Let's ask the AIs. Does do React Native apps run inside of a WebView? I mean, maybe they would have to. Yeah. Okay. So it's fundamentally different from frameworks like Cordova or Ionic, which rely on web views to render UI. That's what I initially thought. Instead, React Native uses native components or bridges to directly interact. Okay, and so here's the rendering of micro tasks. I don't know if... I mean, they're good at text now. They were really bad at adding text to images for a while. Okay, so I still don't have a sense of where actually we hand off to iOS, and part of that is that it doesn't seem to be labeled well in the code. I don't know how to search for it. But here's React Android. I think just by accident I found. Good work. Thank you. Sarab Singh. Thank you. So let's look at React Android. Maybe the Android stuff will be a little bit clearer to me, and I can try to figure out how it works on the iOS side a little bit better. So I'll open Bridge and Runtime. Touch, I'm going to guess, is going to be support for like touch events. And then we have the base React package, which is now in Kotlin. I don't know how they decide whether to write something in Kotlin or Java. We have a React activity, a React application, a React fragment. So these are different UI. So fragments, like a fragment of the UI. The activity is like the main kind of entry point. It's kind of like a page of a website. And we have a React root view. So we'll look at, I guess, a couple of these. So JSC runtime is one we just looked at. And that's a tab that we don't need. So here's the, what? I think this is not in Android yet. Oh, it is. Okay. So what do we want to see here? Arguments, no. Queue, no. Callback implementation, probably not. Dynamic inspector. JS application. Native map, native array. Promise. I thought that there was a better entry point that I had opened. Here's React instance. base React package, React activity. Let's try. React instance. Okay, so the package is runtime. We're going to do a bunch of Java-ish import stuff. So we're importing everything. This is final class, React instance. And we have a bridgeless React context. I don't know what that means. So I guess bridgeless somehow. And some Q stuff. Fabric UI manager. I don't know if Fabric is an Android thing, but something about the UI. And then this looks like some constructor. And some sys trace, begin section. I'm guessing that's program tracing. We're going to configure some Q. And we have a timer. And more timer management stuff. We have a JS runtime factory that I guess we can use to create JS runtimes. I don't know what hybrid data is, but it's going to take some arguments like the runtime factory, the message queue, and blah, 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 blah. I'm guessing the message queue is to like queue up tasks that maybe can also be consumed by the JavaScript and C++ sides. That might be a way of, that might be a queue that crosses the foreign function interface. Then we're adding some packages, like core React package, and this bridgeless stuff, get dev support manager, get default hardware, back button handler, and some other stuff. So there's lots of stuff here. We're doing lots of work, whatever an event beat manager is, maybe beat in the sense of like the beat of a song, like the regular pulsing of events. Load library, load JS bundle. We're going to call bundle loader load script. Some more delegates. This is very Java-ish. Get native module. I don't know. None of this like really stands out to me as obviously connecting with the other stuff we've looked at so far. So I feel like this is maybe not quite the place to be. Surface implementation, probably not. React host delegate. Runtime factory. SO loader, load library, run instance. So what is SO loader? It's something I saw before. And then we have this Hermes folder. We have a Hermes instance. This is going to be, I'm guessing SO loader is going to be like a shared object in the sense like we're going to load the C file there. Hermes instance is going to be something about the having a reference to the runtime, SO loader, load library, Hermes instance, JNI. JNI should be the Java native interface. The Java native interface. Okay, we'll close that. Here's base React package. I don't know if this is going to be any better. It's Kotlin, so it should be at least a little bit cleaner. We can create native modules. We're going to extend React package. We can get a module, get native module iterator. So we have a bunch of native modules. You can get the view managers. We pass in the React context, which is the React application context. And we're going to return a list of module specs, which is an empty list. So see if we can find this thing. React application context. It's an abstract class. And we're just going to call it get application context on whatever was passed in. Yeah, so I don't know. Here's React application.kt, and there's not much here. We have the React native host. So somehow these are going to communicate. That might have been in the big file that I kind of just rushed through. Here's React fragment. It's going to implement permission aware activity. I said fragment was a UI thing. I think it's more of an activity thing, which has a pretty close mapping to a UI, but not exact. You can get a new instance. We're doing stuffing things into Android bundles. And onCreate is a lifecycle method. And somehow we're going to, okay, so get React native host. get the React Native. So host, we saw host in some of the C++ stuff. So maybe the host it's referring to is the React Native bit that's going to play host to the like Android stuff. Or maybe the React Native stuff is like the Android entry point that's going to play host to the JavaScript stuff. I'm not sure. But at any rate, we're going to get a React Native host by doing what? We're going to call get activity, get application. We're going to cast it as a React application. And then on the application, we're going to call get React Native host, which has the same function name, but now it's part of the application as opposed to the fragment. So I think that was the file that I had just closed, right? Let's just try searching for get React Native host. Did I copy it? No. So React activity, React fragment, React activity delegate, React delegate, headless something or other blob provider. Oh, I guess it's part of activity. And we return m delegate. And then where is m delegate assigned? Oh, it's a React activity delegate. The delegate class for React activity. You can subclass this to provide custom implementations. Okay, so we have an activity. It has an activity. It has a main component name. And I'm thinking it's going to also have a reference to the React thing, which might be this React delegate thing. Prefer using React activity when possible, as it hooks up all activity lifecycle methods by default. So this launch options get React Native host is going to get the plain activity, get application, get React Native host. So it doesn't seem like the application is where the real work is done, but we'll look up React delegate. What are we importing here? Okay, here we are importing bridge. Okay, so it's the delegate that seems to be the glue between the Android world and the JavaScript world. And I guess it makes sense to call it a delegate. I think the idea there is that the Android activities are going to delegate to the real implementation, which is the React implementation. And so the Android stuff is really just a shim layer that should be basically the same across all React apps. And the difference between one React app and another is in the implementation of the JavaScript layer. So this one is deprecated. So a React delegate has an activity, a React host, which is the thing I guess we ultimately get by calling that get React host or whatever method, an app key, and some launch options, which is a bundle. And we just when we create this, we call those methods. So somehow when we create this, we have some React host. Let's see what React host looks like. I'm guessing React host is very bridgy. A React host is an object that manages a single React instance. A React host can be constructed without initializing the React instance and will continue to exist after the instance is destroyed. So we have some lifecycle stuff. The lifecycle state for the React host. We have the current React context. Some stuff about dev support manager. I don't know what that is. Some stuff about queues and memory pressure, whether we press the back button. Some lifecycle stuff like on resume. And this is, so we've seen Surface, the folder name, but I haven't looked at it, but I'm guessing React Surface is about maybe like functions like drawing the UI layer, some sort of canvasy sort of thing. And we're seeing some like lifecycle methods here. And are we implement? So we have bridge the common lifecycle state, React context, task. Well, that's not common. I'm not sure if that's specific to Android or not. But this stuff, I guess, is common. Let's try looking for React context. So here's the Java entry point. Is there a corresponding C entry point? How about bridge React context? So this is in React Android still. We have some event emitter stuff. This is the bridge-specific concrete subclass of React context. React context has many methods that delegate to the React instance. This subclass implements those methods by delegating to the catalyst instance. I don't know what catalyst is. You need to create a React context within a bridge context. Please create bridge React context, or rather, if you do, then do that. Okay, so now this is looking promising. So we'll figure out what catalyst instance is. I don't think we've seen that word before, but this should be stuff that calls the native code, like we can get native modules and so on and so forth. So let's look at Catalyst. This provides an implementation of the public Catalyst instance interface. It is public because it is built by X React Instance Manager, which is in a different package. Okay. This is some stuff, I guess, about some sort of tracing. We have a class about appending a JavaScript call and JavaScript module registry, and we're working with JavaScript stuff. But I don't know what a catalyst is. Let's try catalyst. Wait, did I spell it wrong? Catalyst JavaScript. I don't know if this is. Now let's try React Native. I don't know if these are the same catalysts. It's a UI toolkit. Move as fast as you can with the UI library without compromising your own vision. Okay, so but where does Catalyst instance come from? Let's just chase this all the way down. Implements Catalyst instance, public Catalyst, blah, 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 blah. That's a method to get one back. This seems to be a C++ implementation, JNI. So JNI, again, should be the Java native interface. This is the C++ side that Java calls. I still don't know what Catalyst is. Do we include anything Catalyst-y? Catalyst. We're just including the header. Let's ask for the header. Okay, so in the header, we're including a bunch of common stuff like call invoker, native method invoker. We're really getting close to the stuff that we've looked at before. I still don't know what a catalyst thing is. We've got this hybrid class, the JNI hybrid class of catalyst instance. And we've got this implementation. Let's try one more time, just searching for catalyst. Mac catalyst enabled. Main interface for providing additional capabilities to the Catalyst framework. Is it just the UI toolkit? I don't know. You can try Android Catalyst. Hello. Hello, No Goodness. Good to see you again. All right. I think we have to ask the AIs. Let's ask Gemini. In React Native, what is a Catalyst instance? It's a core component within the React Java. A Catalyst instance is a core component within the React Native architecture, serving as a bridge between the JavaScript and native worlds. It is responsible for managing the JavaScript thread, communicating with the native modules, handling the React Native bridge, managing the lifecycle of native React components, etc. Some common issues are the Catalyst instance has disappeared. So where is the is this unrelated to the Catalyst UI framework that uses Tailwind? I'm going to ask for other documentation. Is there of Catalyst in the React docs? No? So I don't know. That does seem to be an accurate description of what it is. Although the client is a single page React application. I don't know. I don't know what to believe. It's a core component. I don't know. I feel like what I've what I've noticed, and this might be just a little bit judgy of me as a former Googler, is that what I've noticed that Meta doesn't seem to really describe what they're up to so well. Their comments sometimes leave a bit to be desired in terms of like documenting what they're up to. But I'm guessing that this is just the thing that it is. It's just the layer. So in chemistry, it's a substance that is used in small amounts relative to the reactants that modifies and increases the rate of a reaction without being consumed in the process. So I think of a catalyst as something that like kicks off something that makes it happen. But I'm guessing that maybe it's used in the sense to mean it's a small layer between the important layers of Java/Android and maybe JavaScript/React. And maybe they're thinking of it in those terms, and that's why it's called Catalyst. I'll say make a painting, make a 19th century American painting of a cattle list in a field. There you go. It doesn't look much like a list, but that'll be fine. Okay, so I guess that's what Catalyst instance is about. I don't see a lot of documentation suggesting that it's anything else or that it's related to the. Although a Catalyst view must have an explicit width and height given to it. This should be normally happen as part of the standard Catalyst UI framework. I mean, maybe it is. Let's try another thing. Let's try a new chat. So in what is the boundary between C++ and Java in React Native code? It's the JNI, it's the React Native Bridge, which is what we've looked at. I remember, so Friction says, I remember learning Catalyst in chemistry class. I really find it awesome when they use meaningful names like that. Yeah, I think that is good. Meaningful names are good. I think like metaphors are really powerful, but it would be nice to know what exactly they're referring to. Okay, so I think that's what this is. They might use the Catalyst UI toolkit, but I'm guessing they don't because they have to use the native toolkit. But let's take a look at the packages.json or package.json. Maybe we can find out what the JavaScript dependencies are. I'm not sure which one it is. We've got some Gradle stuff, a couple of things that seem to be package.json-y. I don't know what metro config is. And it might be the, here, the root one. Yeah, I don't know. Okay, so let's just assume that that's what Catalyst is. And then let's take a look at, see if we can see some JavaScript, which I don't think we've seen any JavaScript at all at this point. And I'm not sure what we would see. So I'm mildly curious about what the bots are up to. So React Common and React core modules. I think we really focused on the bridge, which is probably the right thing to do. Base, RCT assert. So these are going to be more bridge stuff. Bridge proxy. And then MM. Okay, so RCT seems to be iOS specific. So we have headers, but then I'm guessing MM is like, if .m is Objective-C, I'm guessing .mm is C++. So this should be the iOS version of some of the Android code we just saw. And I don't know where you would see things like where you take JSX and that becomes some function. But maybe that's in the React repo and not here. Here's a scroll view. This should be an iOS scroll view. And I think I used scroll view essentially as an example before. But whatever this means in Objective-C world, we have some presumably pointer to a scroll view. I'm going to guess this is a cast. So we're casting whatever super view is as a RCT scroll view, I assume. And then if we don't have one, we're going to return. And then we'll do an assert saying that the scroll view is of kind. The kind of the scroll view is, I guess, a subset of the class of, or maybe literally the class of a list of scroll view things. Otherwise, this seems to be some sort of error, unexpected view hierarchy. And then we're going to call scroll view update content size if needed. I don't know if that's also a return. But somehow this is doing some stuff. And here's the React fragment. I think this is all just stuff I had open from before. Is root view worth looking at? We're including just about everything, including the UI manager, the bridge. Root view is going to extend frame layout. Default root view for Catalyst apps provides the ability to listen for size changes so that a UI manager can relay out its elements. It delegates handling touch events for itself and child views and sending those events to JS by using JS Touch Dispatcher. Okay, this is useful so that everything, when you touch the phone, the Java doesn't handle that touch event at all except to just dispatch it to the JavaScript layer, which is essentially what you want. And so on. So this is going to be a mildly interesting implementation. This is an important part of the layer, but we're going to just move on, I think. Here's a hello world. Is this worth looking at? We have app.jsx. And we have the safe area thing, status bar. So where do we get those? So safe area view, we're importing from React Native. That's a unique enough string as opposed to text or view. So this should be something that I could search for. And we get this libraries component safe area view. I think this is an iOS specific thing. I don't know what d.ts is. I'll move this to its own folder. This should give us an example of one component, and maybe we can see, kind of trace through how it's implemented. And then here's an example. I guess that calls it. Safe area view.d.ts. This looks like type information. We're going to import constructor, I guess, from utilities, import native methods from React Native types, and view props from view/view props. And then we have this comment here, renders nested content and automatically applies paddings. Reflect the portion of the view that is not covered by navigation bars, tab bars, toolbars, and other ancestor views. Moreover, and most importantly, safe areas paddings reflect physical limitation of the screen, such as rounded corners and camera notches, aka sensor housing area on iPhone X. Okay, and so we're declaring some classes. So safe area view component extends React component of view props. So React component is really general. I don't think we saw this class, but this might be part of the module stuff, but this is something that's bigger than an object, I guess. But it's going to extend view props. I guess it has view properties potentially. And then we have a constructor, which is going to be templated by native methods with this type of thing. I'm not sure what that's about. And then the safe area view is going to extend safe area view base. So this seems to be typing information. I don't know what the .t stands for. Maybe this is TypeScript. At any rate, here is safe area view state .h. And we just really have this constructor. I don't know what folly is, but there's something about dynamic data, and we have we're going to give it some padding, which has this weird, this seems to be some sort of map, data of left dot get double, data top get double, etc. And then we have this folly dynamic get dynamic. There's probably some sort of dynamic typing stuff. Here's another header for the node. What I want is wasn't there an M file? That was the shadow node. Safe area view. Is it the same file? Okay, we can look at the state at least. We check if it's Android. We do this folly dynamic safe area view state get dynamic. And whatever this is, we're going to call on the folly dynamic object, passing in this kind of weird, crazy stuff. It looks like on object, this is C++, right? We're calling this function, and I guess that must return a function that we're calling this on, and so on. So this maybe some kind of functional encoding of stuff. Let's look at what folly is. React Native pods. This is now Ruby. Helpers.ruby. I don't know what's going on here. Cocoa pods. RCT folly convert. Include folly / dynamic. Here's JSI dynamic. I don't know if this is if folly is a necessarily React Native thing. Folly docs. Okay. Volley is maybe a Facebook/Meta thing. What is Volley? Volley, acronymed loosely after Facebook open source library, is a library of C++ 17 components designed with practicality and efficiency in mind. Volley contains a variety of core library components used extensively at Facebook. Okay. So this is some Facebook library for, I guess in this case, dynamic, like runtime typing stuff. I don't feel like I feel satisfied that I understand exactly how this handoff goes between the safe area view and the JavaScript side. We did see what looked like some TypeScript, and like morally speaking, what it's going to do is it's going to look over the foreign function layer into the land of iOS objects, get some sort of like Objective-C pointer to the safe area view and allow you to manipulate that with JavaScript. I think you've used Volley. Do you remember what you used it for? And then here's the safe area view example. And this is in JavaScript. We're creating some class. We're going to extend React component, setting some modal visible stuff to what? I'm not sure. I feel like I've used React before, and I vaguely recall this notation, but I don't really remember what it is with the mustache pipes. And then we have the render method, and we're going to return view of model, telling it stuff about whether it's visible. And then we've got the safe area view thing here that we're passing in more view information to. And there should be some JSX library, I guess, that's probably part of React. And that will be responsible, I guess, for turning this HTML-like syntax into like a standard JavaScript call. And then the JavaScript will be using some of the stuff we've seen to call the corresponding iOS stuff via the bridge. Let's see if there's any JSX. What references to JSX we have? Here's a hello world. This might be defining some JSX stuff, like custom JSX. Function app React JSX element. No, it's not. It's just using JSX. So where's my search? Here. Okay, this is maybe just like CI stuff. React Native libraries lists, flat lists. Okay, so get scroll responder is a void thing that's going to, I guess, return a JSX element, a null or undefined, provides a handle to the underlying scroll responder. Okay, so somehow we do have some JSX elements. We have some plugins like plugin transform React JSX. Oh, we did see some. There was a transform library. I wonder if that's part of this. How do I get back? Scripts, tools, packages. Wasn't there a transform? Oh, Babel transformer. I think that's probably different, but let's check out bots. I had forgotten about bots. Code analysis bots. Danger is a JavaScript runtime which helps provide continuous feedbacks inside GitHub. Okay, so this is probably bots for like build bots. Okay. I feel like we've basically seen everything. I want to satisfy myself that the JSX layer is not interesting, but first of all, let's see if there's a JSX repo. There does seem to be. Well, at least this is the specification. An XML-like syntax extension for ECMAScript is not a proposal to incorporate JSX in the ECMAScript's blah, blah, blah itself. So let's look at the React. I'm assuming it's just called React. And let's see how they refer to JSX. Node traverse JSX, create JSX equals true. Yeah. So it looks like this is all implemented in the React layer, and I'm somewhere there should be some JSX stuff that basically says like the thing inside of these two angle brackets is an identifier, and then once you have that identifier, they're just going to look up in some sort of table, some sort of runtime object, what that identifier maps to, like as a JavaScript object, and then they'll basically have to do the same thing one layer down, handing off to C++ after the interface to the bridge. I guess maybe the very last thing we can do is we'll look up bridge and see if, oops, we can spell it correctly. And we'll see if there's any big part of JavaScript that we missed. Probably JavaScript and not TypeScript, but I'm not positive. I don't know if GitHub is smart enough to know that TypeScript is kind of like JavaScript if I do a search for this. So we see some stuff in feature flags, unit tests, batched bridges. This is, I think, a libraries, I think, is iOS specific. Generators. Maybe generators is part of what we're missing. Blob manager. Again, I think libraries is iOS specific. Yeah, I'm guessing generators. I'm guessing that maybe why generators, probably because they're probably going to generate the bindings for each individual view. So there should be a lot of boilerplate around like, you know, a list view versus a scrolling list view. Once you know the number of arguments or whatever that need to happen, I think you should be able to generate the code to actually bind between those two layers. So let's look at this, a couple of these generators. Generate module JNI, generate JNI CPP, generate Java spec, generate module H, generate module CPP, generate module Objective-C, struct collector, serialize event. So let's just take a look at a few of these and just test the hypothesis that this is about, that they're ultimately using generators for the toil of doing per view loading and stuff. So this RNC code gen, this is JavaScript. We've got some sort of schema validator, generate component descriptor, C++.js, component descriptor, et cetera, generate props, generate state. So where is this? These are in components. Let's move this to its own thing. We have parsers. Yeah, this is looking promising. How about generate something? Generate component descriptor.h. So we have some sort of file template, a library name, a component definition, a header prefix. This code was generated by React Native Code Gen. Okay, so this is not a comment in the code. I think this is a literal string that we're going to output. This is going to be written to the header. And we have this pragma once thing. And we're doing it in JavaScript. I think we're just using templating. So we're going to include template header prefix file shadow nodes.h. And we're going to include the concrete component descriptor.h, which I don't know where that is. I mean, it's obviously here, but we haven't seen it. It's going to be in the namespace Facebook React. And then if we had React Native installed, which I don't think I do, we should see a bunch of these files generated. And then we have this register component descriptors from CodeGen. So this is just generating a C++ file with a boilerplate. And I think that what we're doing is what I speculated we were doing. Somehow we should know something about arguments. I'm not sure where that is, but it's somewhere. What else is templated? We're going to map the module name to, we're going to look up in this schema. The schema, I guess, has some like map of modules. We're going to get the module from its name. If its type is not component, we're going to ignore it. And then we're going to take get the components from the module. If the components are not null, if the components are null, we'll return. Otherwise, we're going to get the keys from the components. And for each key, I guess the key is a component name. We're going to look up in components and check if it's an interface only, in which case we ignore it. Otherwise, we return component definition template, and then we join on the new line. And we filter. I don't know what filter Boolean does, but then we join a new line again. Okay, so this seems to me like it's doing what I thought it was doing. I don't really understand the details. We could understand the details more if we looked more at the source codes, but let's look at this generate object C++ stuff. Okay, so we got the module emitter, module template, whatever haste module name is, passing in some structs. Where did structs come from? I'm not sure. I guess it's just some argument to the template. And it's going to be a read-only array of struct. We have a module name, event emitters. I don't know. I don't know if event emission is something that's part of the Android and iOS APIs, and so this is just a generalization of both, or if this event emission stuff is specific to React Native, I'm not sure. And some serialization outputs. And it seems again like we're going to just do like string manipulation to create some code generation. We have this convert category template, etc. And here's generate module C++, and seems to basically be the same stuff. We see some static JSI value, host function, haste module name, etc. Okay, so that's I think what we're doing. I don't know if there's a fast way to. Let's try. Let's try just verifying if we can see like what some of this generated code looks like. I don't know what this production stuff is. All right, never mind. This is too complicated. Can I just do like npm install React Native? No, not even npm is installed, so forget it. Let's just look for React Native generated code. React Native uses a combination of JavaScript, which you write in native code, which it generates to build cross-platform mobile apps. Okay, so CodeGen is a tool in React Native that generates native code from your JavaScript code. This allows your JavaScript to interact with native components, and it runs automatically when you build your app. It generates native modules. If you create a native module to access platform-specific functionality, CodeGen generates the necessary glue code that bridges your JavaScript and the native code, and also turbo modules. Okay. So I consider that case closed for what the generation is about, and that tells us why we didn't see the stuff that I was looking for. Like where are the two sides of the scroll view? One side is obviously going to be in the Android or iOS SDK. The other side should be something that looks like JavaScript and is able to communicate to the SDK. And the answer to like why we didn't see a bunch of that stuff is that it's code generated. And So Friction says that they were struggling before with React Native because they were new to it. If they had found this stream back then, it surely would have been so helpful. Well, I'm so glad. I'm sure it would have been helpful to me to have taken the time to explore it. I remember it being not so bad. The hard part with all of these frameworks, I think, is if everything's going right, like the tutorials, then it's smooth sailing. But when something goes wrong, then all of a sudden you have to know not only JavaScript, but also not only JavaScript and the underlying platform like iOS or Android, but you have to know, kind of understand how the layers hand off to each other, like where in that flow something could be going wrong, and all of those things. So the more magic there is, the harder it is to kind of debug the magic. But it's open source. You can explore the code, which is what we've done, and you can try to understand some of the magic yourself, or with us, your friends here at Answer Everywhere. And so with that, I'm going to leave you. So have a good week, have a good day, and I'll see you again soon. Thanks for watching.